Hey guys, welcome back to Cop 12. This is Rob, and I'm here at STAFDA 2018. We're here to talk with Russell from Diablo. We just saw this awesome presentation you guys did. We appreciate you turning the lights up so we can see it a little better because we want to show it off. We've got a whole bunch of new Recip blades here. What can you tell us about them?
Well, we entered this category, Rob, about 5 years ago because we felt like we could bring real solutions to this industry, and it's a huge industry. It's growing very quickly, as you know, with the cordless momentum that's happening. But the current designs right now, we felt like just weren't getting it done with users. So we really redesigned the bi-metal category, and we introduced a brand new category called carbide tip, which was really first in the world about 5 years ago.
Gotcha. So now, but today you actually have some new examples, don't you?
Yep. So let's start with bi-metal. The first thing we noticed, if you look at the category, it really was born through stationary bandsaw blades, which is long strips of steel that are punched out. So really, everything's not very individual. It's just kind of cookie cutter.
Sure.
So some of those designs lacked a lot of performance variable that our users were looking for. So we make every blade individually. And so we actually kind of learned.
So you don't use the traditional, take a long band and punch those out.
That's right. So we're able to design every blade individually.
Okay.
And so what we took it off is very similar, this design, to a handsaw that has very small teeth that progressively go to larger teeth. And what that does, if you can see here, I'll show you here, I can zoom in.
Yeah.
The small teeth, the larger, creates like a pilot and reduces vibration, and then letting the bigger teeth at the end kind of pull through, being very aggressive.
All right.
And so this delivers significantly better performance than really any other blade in the market.
Okay, that makes sense.
Yeah.
Do you guys have a demo for us?
We do. I'm glad you asked.
All right, Russell, what exactly are we going to see here in this demo?
Okay, very simple demonstration. We'll compare our bi-metal blade to a bi-metal Milwaukee. Milwaukee's a great company. They do a lot of good things, right? But we're focused. This is our.
We've heard of them.
Yeah.
Sure.
So it's a very simple test. We're going to let the tool do the work. We have 4 nails. We have 3 screws, a very common application. Both the tools are set on the same settings. We have a 5-pound weight to create no bias, so there's no operator differences.
So we're just going to let the weight pull it through the wood. We're not going to have any of the guys putting pressure on them.
And we'll see if this technology really can deliver like what we're talking about.
Sounds good. Let's see it.
Ready on my count? 1, 2, 3, go.
All right, I don't know if I'm gonna be the first to bring this up, but I feel like we need a photo finish because that was super close.
Right?
Like I'm not entirely sure which one won. All right, so there was a major difference. That happened way quicker.
Yeah, and that's what this technology, the small to large, that variable pitch, it keeps the vibration down, keeps the smaller teeth cutting the nails, but the aggressive teeth at the end can pull through. So you get both reduction of vibration but speed.
Awesome. All right, so what's next?
What's next? Metal cutting.
All right, Russell, so now we're talking about metal cutting, right?
Yes. So metal cutting is about 65 to 70% of the applications, right? You generate a lot of heat, and this is where somebody, the cheapest part of this whole component in cutting steel are the blades.
Sure.
Tools more expensive. These guys, labor, trust me, they're a lot more expensive.
They look very expensive.
The cheapest thing are the blades, and so really, and the interesting thing is that delivers the most amount of performance. So what we found in the marketplace is standard blades cut with one tooth, and all the teeth behind it are kind of in the shadow. They're hidden behind the standard tooth. So we created what's called an arc, in a way, we call full contact. And what it does, it puts all the teeth in the material so that first tooth doesn't block it. So by having that slight arch, you're able to get more teeth in the material, and that way it cuts faster, reduces the heat, and lasts significantly longer. So to prove this out here, we have a very simple demonstration. Schedule 40 piping, 1-inch pipe. And we're going to do the same example as we did before. We're going to let the tools do the work and drop. However, we're going to make a total of 3 cuts.
Okay.
And we're going to time each cut, and we're going to write them up each time for each cut. So we're going to try to prove 2 different things. One is speed, but also consistency.
All right.
Between the 3 cuts. So
I was going to say, with creating, using the arc, making it more aggressive, as you make a less fine cut, are there messier cuts?
Well, let's see.
All right, good. Let's see.
So typically, more teeth in material, good things happen.
Right.
Less teeth, worse things happen. So let's see if we can prove it out.
All right, here we go.
On my count, 1, 2, go.
All right, let's come over here and look at these numbers for a minute. So, okay, clearly there's a story there. So, and I saw the Milwaukee did dance around a little bit on that last cut, but not enough to change these numbers very significantly.
No, you can see you can see how it actually is taking longer each cut, where the Diablo's making fast but consistent cuts.
That's amazing. All right, what's next, Russell?
What's next? Okay, let's hit carbide, huh?
All right, Russell, let's talk about carbide.
Well, we were the first in the world to come up with a carbide tip reciprocating blades about 5 years ago. And our first version was in nail embedded wood, which you think about it makes so much sense, right? When carbide comes into any category, it dominates. Circular saw blades, almost 100% carbide. Hammer bits, router bits. When carbide comes in, it takes over. And this category lacked any type of carbide technology. So we're the first in the world to do it. We came out with a nail-embedded blade that really changed this industry. And since then, more and more of our colleagues are entering the business, which is a positive thing.
Of course.
Right? It's a form of flattery, and it's good for good for the industry because now more people are talking about it.
Sure.
So what we're going to do today, though, is show how our carbide, which we're already on version 6, we continues to innovate in this area, is a little bit different than where the market is today.
Okay. All right. So we have an example here with 1, 2, 3, 4, 5, 6, 7, 8, 10 nails on the side of each one.
10 nails.
All right. And what are we running up against?
Well,
we got another Milwaukee blade.
We have the Milwaukee, the new carbide tip Ax.
The Ax, yep.
Versus our carbide tip Diablo, like for like, nail embedded wood.
And once again, we're going to use weights on the actual Recip saws, so they're going to be putting no pressure on them at all.
Yeah. These are masonry fluted nails. They are hardened nails. But yes, we're going to start underneath, so there's no pushing on the top. So we'll set the pilot and then let the tool do the work.
Sounds good. All right, good luck, guys. Once again, another photo finish. Yes, well, that's remarkably different.
Now we're going to be a little obnoxious here. We're going to kind of flex our muscle. We're actually going to take a brand new Lenox blade, and assuming you're comfortable here, Mike, and we're going to use the same Diablo blade that we just used in the first half. We'll do another run versus a brand new Lenox blade. Anything can happen in a demo, especially when the camera's on. Well, let's give it a go when you guys are ready.
All right.
All right, we'll put it out of its misery.
I appreciate that.
I mean, look, at the end of the day, it starts strong and it stays strong.
Yeah, that's amazing.
That's the key thing. So.
Awesome. Thanks, guys. So we've got one more thing to look at.
One more.
All right, Russell. So we've got our fourth demo here. This time, it looks like we're using metal carbide blades. What are we doing?
Well, you think about metal cuttings. We talked earlier, 65% of the market. But talk about a great game changer opportunity when carbide comes into this, because you're generating so many high heats. And carbide tip Recip blades didn't change the market forever in terms of just cutting mild steels. It now allows you to cut steels you couldn't even think about with a Recip saw, such as boron steels, lightweight advanced steels, cast iron, and even stainless steel, what we're showing you here. So in the past, you had no chance to cut this with a Recip blade. Now you're going to see cuts like butter.
All right, so what are we running up against today?
Okay, so we got a very simple demonstration here. We're using the carbide tip new torch by Milwaukee versus our carbide tip thick metal by Diablo. Both are like-for-like blades, designed for the same thickness, same application. Again, we're going to let the tools do the work. We'll see what happens.
Sounds good. Let's go.
Start strong, finish strong.
That's unbelievable. All right. Well,
it is. And then we're ready to last. Independent testing shows 5 times the life of this carbide tip torch. So look, you're looking at a whole different experience, and even Logan was rocking it at the end to help it get through. So actually speed up on the time. So, but just think about when you're doing this 6 to 8 hours a day, and that's what these users are doing. They cut steel all day long. Significant performance. And when you have tools like lithium-ion talking about, hey, we last 7% longer than that battery pack, or our charge can, we can cut 5% faster. Just by changing the blade, you can double or triple, in some cases, a 5x factor versus what's currently being out there.
Because it's more efficiently cutting through, because the blade's more efficiently cutting through. You're putting less wear and tear on your on your motor in the first place, but you're also using less battery, so it's going to last longer.
That's exactly right. When you optimize your cutting performance, that's good for corded and cordless. It's good for the motor, less amp draw, good for the user from a vibration standpoint, and it's good for the battery. It extends the life of the battery.
Awesome. Thank you, Russell. We really appreciate your time. Thanks, guys. We really appreciate all the tests. Guys, we have a bunch more yet to come from STAFDA 2018. We'll see you soon.